understood with the help of this small diagram or this picture of the figure, which is depicting the three main facets of eco innovation. That is, who are the targets, what is the mechanism that go undergoes, and what is its impact. So, eco innovation targets here they're given institutions, organizations, marketing methods, processes, products. And eco innovation mechanisms are modification, redesign, find the alternatives, and creation. And when you talk about these three things, that is institution, organization, and marketing methods, under this we have primarily non-technological change and higher potential economic environmental benefits, but more difficult to coordinate. And under processes or products, primarily we have technological change. Next is sustainable manufacturing calls for multi-level eco-innovations. Here, if you look at your conceptual relationships between sustainable manufacturing and eco-innovation. Eco-innovation targets, here again, as we know, the institutions, organization, marketing methods, process and products, and eco-innovation mechanisms, modification, redesign, alternatives, and creation. And under that, eco-innovation mechanisms, we have pollution control, cleaner production, eco-efficiency, life cycle thinking, closed loop production, how it happens, and in industrial ecology. This is not technological, and the remaining part is technological part. Eco-innovations, if you just look at here, which can be understood with the table, where it talks about industry and its company or association and eco-innovation example. If we take about automotive and transport industry, the BMW group, the Toyota, Michelin, and Velib, here improving energy efficiency of automobiles, sustainable power plants, means Toyota, whenever they do, they have sustainable plants, and energy saving tires, and self service bicycle sharing system. And when you take the iron and steel industry, Siemens and VA, etc., they have alternative iron making processes, and UL SAB and AVC, they have advanced high strength steel for automobiles. And electronic industry, they have IBM, Yokogawa Electric, Sharp, and Xerox. And IBM is like energy efficiency in the data centers, and Yokogawa and Electric is about energy saving controller for all air conditioning, water pumps, and Sharp is for enhancing recycling of electric appliances, and Xerox is managed print services. Mapping the focus of example of eco-innovation. Same again, institutions, organizations, and marketing methods and process and products, how actually they place it has been depicted. And modern manufacturing technologies, when you architectures, standardization, and even definitions of flux. And most of Industry 4.0 initiatives are early stage projects with a limited scope, and the majority of digitization and digitization effects in the reality happen in the context of third and even second industrial revolution and technology goals. And here, in a sense, the technology make Industry 4.0 possible, leveraging existing data and simple additional data sources, including data from connected assets to gain efficiencies on multiple levels. Here you can see the digital transformation, third platform innovation accelerators, OT and manufacturing meet in transformation, Industry 4.0, Internet of Things, cybersecurity, augmented reality, big data, automotive, robotics, additive manufacturing, simulation, system integration, cloud computing. And if you look at here, Exhibit 9.2, which talks about from Industry 4.0 to fourth industrial revolution. So the first one you can just see mechanization, steam engines, water or steam product or steam power, new manufacturing, iron production, textile industry, mining and metallurgy, machine tools, and steam locations. When you go about the second industrial revolution, it was like technological electrification, production line, mass production, globalization engine, turbines, board, uh, turbines, broad adoption of the telegraph, gas, and water supply. And when you look at the third industrial revolution, computer, internet, digital marketing, PLC, robotics, IT and OT, digitalization, automation, electronic or digital networks or digital machines. And 4.0, which is convergence, IT, OT, autonomous machine, advanced robotics, big data analytics, Internet of Things, digital ubiquity, cloud smart factory, machine learning, and AI cyber physical. And also, you can just look at here automation pyramid to industrial transformation with Industry 4.0. The components of Industry 4.0 are system integration, big data and analytics, simulation and virtualization, Internet of Things, the cloud, cybersecurity, autonomous robots, augmented reality, additive manufacturing. And if you just look at the figure or the exhibit, it's the convergence and application of industrial technologies according to the Boston Consulting Group. And the benefits of Industry 4.0, here we have increased efficiency in production, more potential for innovation, accelerated response to customer needs, reduced cut cost and higher profit margin, quality assurance, and fluid collaboration. And here, fluid collaboration, just look at here how they all work together. That is predictive maintenance, smart sensors, big data, sensor fusion, IoT, cloud computing, advanced algorithms, and automation. Industry 4.0 challenges. The challenges because both there are some other real-time challenges, that is data security, trained human resources, the lack of trained human resources, team support, leveraging data, and high cost. Internet of Things. Defined by its name itself, it's a network of machines or digital devices, and it can be considered as child of digital innovations and internet. And it's an in an IoT based network, number of machines which are enabled with digital data recorders with unique identification will communicate and share performance metrics to and has the potential to guide the production process in many predefined environment. And intelligent robotics is the new generation manufacturing tools, those replace considerable amount of workforce and improve the production rate. Robotics in manufacturing has become significant from 2013 and with record sales of 7 lakh 79,000 across the globe in that year. So many bulk manufacturing industries, automotive manufacturers used robotic arms in the production. And the IoT has advanced the robotic technology with an internet based sensing systems. So here thus making the IoT has advanced the robotic technology with interface sensing system, thus making it intelligent. And sometimes what happens, machines vision developed with the help of various cameras and sensors have made the movements of robotic arms on the production of line flexible, accurate, and consistently in a continuous operation. Next, we discuss modern manufacturing methods. So, what are the modern manufacturing methods that are involved and that are there in the manufacturing system? So, here we talk about guiding principles of modern manufacturing methods: waste reduction, production, product quality, mass production, adaptive control, rapid prototyping, nano manufacturing, production support systems, computer aided simulations, non traditional machining process. So, manufacturing method is a process of converting raw materials into a designed finished product with certain principles. And in general, any material is processed through removing or forming, shaping, and assembling. Since the Ford model of the production line, there have been many concepts developed in order to optimize all kinds of resources in the manufacturing. The aim in such approaches is to improve production and making it cost effective. The major management theories suggest such enhancements to the process can often create competitive advantage to the companies. Some of the major methodologies of production are just in time, just in sequence, lean manufacturing, etc. And some of the parameters in manufacturing are waste reduction, quality maintenance, and accelerating production. In reference to the sustainable agendas of emerging technologies uh, in manufacturing, improving the above elements is the key concepts or key elements, key context we can take, and this will elaborate more on waste reduction, quality maintenance, and accelerating production. And the guiding principles of modern manufacturing methods we have is waste reduction. Major concepts works on waste reduction, product quality, and mass production. So, how can we reduce the waste that is been taking place in the manufacturing yard? Through by following lean manufacturing, just in time, Kanban, and just in sequence, total TPM, that is total productive maintenance, quick response management, cellular manufacturing, single minute exchange of die, and product quality. Product quality depends on Six Sigma, and the Six Sigma technology has DMAIC, that is define, measure, analyze, and improve control, and DMADV, that is define, measure, analyze, design, and verify. QFD or CTO, critical to quality and quality function development. These two concepts try to pinpoint the elements of a product that are most important to customers and translate those needs into manufacturing strategy, and that focus on getting the critical elements. And SIPOC, that is suppliers, inputs, process, outputs, and customers, is a diagrammatic tool that allow manufacturers to trace the life cycle of their product from supplier to customer and identify problem areas. And Taguchi loss function, if a manufacturer design a production plan that will maximize product and efficiency, and any sudden changes or various from the plan pose a problem. So the Takuchi loss function suggests that production quality decreases, a variation increases. And they're given the Six Sigma concepts. Just look at here: define, measure, analyze, improve, and control. And define, measure, analyze, design, and verify. Critical to quality and quality function deployment, and SIPOC and Taguchi loss function. Next is nano manufacturing. And the advancements in material science and composite materials include nanotechnology and nanomanufacturing. The process that handles nanoparticles for manufacturing products is called nanomanufacturing. In this modern method, products are produced with highest dimensional accuracy and stability. So here what happened, the nano manufacturing techniques are focusing on uh, attaining zero precision. So there are two methods of nano manufacturing, that is top down and bottom up methods. And the main focus areas of this technique is to produce uh, intricate designs and products which are aimed for zero failure. And in world class manufacturing, the products are manufactured on more or less completely automated production line. In such environments, modern innovative technologies such as CAD, CAM, intelligent robotics, additive manufacturing, etc., are employed. And this means the products are at high quality and each can be easily mass produced. So, the application of nano manufacturing is in aerospace, medical, etc. And overall, nano manufacturing is an economic process focused on waste reduction, product quality, and mass production. If you just look at your gauge wire made from carbon nanotubes, it is ply spool made from carbon nanotubers. And the next one is product support systems, computer aided simulations, non traditional machining processes, sub process of NTM, electric discharge machining, laser beam machining, electrochemical machining. So this is about the uh, innovation and the methods or the models that are being used in manufacturing of manufacturing units or manufacturing industry. Modern machining methods, what are the different modern machining methods that are being used and followed in the manufacturing industries. And the next one is automation and robotics. In the automation and robotics, we talk about meaning and reasons for automation, disadvantages of automation, types of automated manufacturing system, robotics, meaning and its objectives, need for using robotics in industries, loss of robotics, anatomy of robotics, types of drive systems, robotic sensors, specification, robotics application in automotive manufacturing, robotic application in space, medical and defense, advantages and disadvantages of robots. So this all we are going to understand how the automation and robotics that are playing a crucial role in manufacturing industry. So when you talk about the introduction about automation and robotics, manufacturers across various industries choose automation to improve quality, boost productivity, and save labor cost. And manufacturing companies can integrate multiple forms of robotics, conveyance, vision, or other automated technology to complete production tasks. And industrial automation and robotics are the use of computers, control systems, and information technology to handle industrial process and machinery, replacing manual labor and improving efficiency, speed, quality, and performance. And automated industrial application range from manufacturing process assembly lines to surgery and space research. And early automated systems focused on increasing productivity, and the system do not need to rest like human employees. They are machines, yes. But this focus is now shifting to improved quality and flexibility in manufacturing and more. So here modern automated systems are developed beyond mechanization with the addition of artificial intelligence and machine learning. And now robots are programmable machines that use sensors and actuators to interact with the physical world and perform actions autonomously or semi-autonomously. Because they can be reprogrammed, robots are more flexible than single function machines. Collaborative robots are designed to complete tasks in similar manner to humans, while traditional industrial robots tend to complete tasks more efficiently than humans. So here the thing about the automated robot automation and robotics that we discuss in the next class. That we will discuss in the next class.